And also I gave one question. Did you solve that question? The mountain problem?
Yes, sir, I solved it.
Yeah, it's easy actually. I mean, you have to use a time actually, because time is given parameter, and here everything is given. So this was a mountain problem. This was a 5, and they had given time that you have to reach there the bunker in the time t. This was a bunker, and this was a tanker something. So if you throw something at an angle theta with horizontal, you can say the horizontal displacement here is how much? D cos phi, which is simply u cos theta into t, right? And vertical displacement is how much? Which you can write as u sine theta minus half gt square, and then it's being this side. And because in theta, you can just divide 1 by 2, not 2 by 1. So 2 divided by 1, what will get? D sin phi by gt square by 2 upon d cos phi is tan theta. The tan theta is tan phi plus 2d cos phi. So the theta is tan inverse tan phi plus. I hope this is clear to all of you.
Yes, sir.
So here we are not supposed to, assume the maximum or minimum range, because they have given everything. If they would have asked the minimum u to reach there, then we would have used the formula. With minimum effort, can you reach there? So in that case, they will not dictate time actually. Now the last variety is something called just Okay. So what is obstructed a projectile motion? Okay. It's something very interesting. Now, there are two versions to it. One is like which you will study in the chapter of center mass. Okay. In a collision chapter. And the other is like that what we are going to study here, with the assumption that the collision is perfectly elastic. So there's something called perfectly elastic collision in physics. And in perfectly elastic collision with a rigid surface, so although this is a part of the chapter of center mass in which you will study in great detail, but many questions you may face as of now in some textbook. So the easier one we should be able to answer at least at conceptual level. So imagine we have a wall like this, and you throw something from here. Let's say you throw at some angle. So imagine if the wall is vertical. So we will see for the vertical only as of now. So if imagine if there is no boundary, what will happen? This would have gone like this. Correct? Now, because of the wall, what will happen? It will make some impact here, right? And this moving wall, will have two velocity component, one horizontal and one vertical. The horizontal will be how much? Tell me guys, what you can write here? U cos theta. And what is vertical?
U sin theta.
Now, when you make an impact, the impact will act in which direction? So as of now, you can just remember that the impact by the wall will act this way. So in case of perfectly elastic collision, the component of velocity along the impact will reverse, but the other component remains unchanged. What does it mean is that U cos theta will reverse after impact, but U sin theta remains unchanged as it is. And we will also consider that the duration of impact is negligible. So it will not spend any time there, it will just come back. So if U cos theta will get reversed due to the impact, what will happen? The journey which you were supposed to travel on the right, the same journey you're going to travel now left. That is the whole idea. Are you getting my point? What I'm saying?
Yes,
This
sir.
journey you were supposed to travel on the right, but as a result of collision, what will happen? The same journey you will just move or travel in the opposite direction. So this wall will act as a mirror, and you can think that the remaining journey will form the mirror on the other side. So it's like image on the other side. So it will become like this. It is exactly the same journey which you could have imagined on the right side. The journey will now happen on the left side. That's the only difference. Is this clear?
Yes, sir.
So your journey will be, you will go this way and you will come this way. So what you need to remember in this case is the vertical component in even after collision is not getting impacted, which means what remains same in the entire journey? What will be same?
Time of flight.
Very good. And what else? The maximum height, isn't it? So the maximum height that it was supposed to travel without making the impact, and now the impact has come into picture. The maximum height remains unchanged. It will go to the same level, but in the opposite direction. If it has not gone before, and if it has gone before, then you know what will happen. So what we really need to remember here is time of flight remains unchanged. Okay. And B, maximum height remains unchanged. It is clear, guys?
Yes, sir.
So if I assume the wall to be at a separation D, how much time it will take to make the impact? Time to go from here to here? That's called T1. Well, that's called T actually. So the remaining time will be how much? So can you tell me how much is the T value here? Anyone? Given the D, how much is T?
D by U cos theta.
Very good. The horizontal displacement is D and the horizontal velocity is U cos theta. So the time taken to reach the wall is D by U cos theta, right?
Yes, sir.
Now, this much time you have already spent. How much time you have left to travel in air? The remaining time is how much? T minus T, right?
Yes.
And what is your horizontal velocity even after the impact? It is U cos theta itself, right? Isn't it? So
Yes.
from here onwards, you will reach here in time how much? Tell me. What is the time from here to here? After impact till you land, how much time you travel for? Tell me. After impact till you land, how much you travel in horizontal direction?
U cos theta into T minus T.
Very good. So if I call this as D dash, so D dash is how much? U cos theta into T minus T, which is U cos theta T minus U cos theta. And what is T here? D by U cos theta. So basically, if you remember the formula, this is the formula for the range of projectiles. This answer is very simple because it's a reflection. So the remaining journey, if this is D, the remaining journey itself we know is a range minus D. So if you take the mirror image, you'll get the same answer. Okay. So what happens is the left out journey will get reflected back. That's it. Is this clear, guys?
Yes, sir.
Yes, sir.
So it's very easy. Just so you will get easy question, not very difficult based on this. The next is So a ball is rolling on this table and there is a well. So if the height of this, let's say well is h, how much time this ball will take to reach the bottom? So its journey is going to be something like this. It is like a horizontal projectile motion. So it will go like this. Assume the impact is not changing the speed, so it will reflect back from here. It will make impact, then it will again reflect back. And it may fall like this. So what do you think? These many reflections will change the time of flight, or the time of flight remains same?
It will remain same.
And how much will be the time of flight by the way?
Under root 2h by g.
Very good. So the total time taken by the ball to reach the bottom is unchanged because only a reflection is happening. Your journey is still continuing in the same fashion. So it will remain 2h by g under root. How many of you remember this formula? Raise your hand. Okay. Very good. So now this is the time of flight, which is under root of 2h by g. They may ask you how many collision it will make. How to find the number of collision?
So 3 collision.
No, this is not a diagram, real diagram. This is just a demonstration. So you need to understand that what is the range of projectile. How far you could have traveled. Range is how much? UT. So it is like you are making the folding of D length. So number of collisions is the total range by the D, and you take the greatest integer, which means just take the integral part. Let's see if R is 100 and D is 9 meter. R by D will be how much, guys? 11 point something, right? So the integral part is how much? 11. So we say there are 11 number of collisions. Understood?
Sir, but why would the ball travel this way? Can't it go straight?
No, there is a like a ditch, no? There is a well. So how it will go straight? That there is nothing in the top actually. This is not present.
Oh.
You are thinking this way.
No, then also.
So when you throw something, how it will go? How it can go straight if gravity is there? Gravity will pull it down.
Right
Yes or no?
down. Yes.
So why it will go
So,
straight?
no, straight means downwards.
So U is there, na? U will take you forward. Yes or no?
Yes.
Horizontal component of velocity will never change, right?
Okay.
So you will always have the tendency to move forward because of U itself. Okay. And
Okay,
it is
sir.
the
Yes.
gravity which is bringing down. So these are
Okay,
like
sir.
two action happening, and what you see is the resultant motion. Okay, it's clear.
Okay, sir.
Yeah,
Yes,
if
sir.
you make U0, it will go down. Exactly.
Okay, sir.
Now, if D itself is bigger than range, it will fall much before, isn't it? If D is much bigger than range, it will fall somewhere here, directly like this. Quite possible. So it is up to D. Okay. All right. So let's solve some miscellaneous problem before we end up this topic. These are like all challenging problems. So this will test your thinking skill, like how much you can think as of now with whatever you have learned so far. So now we have an inclined plane. And this inclination is theta. And the from height h, you throw a ball in the horizontal direction with speed u such that it is hitting the plane exactly at right angle. Okay. How it is hitting? At a right angle. So I have to find the value of u which can make this possible. So find u such that ball hits the plane at a right angle. And the ball is thrown horizontally. Okay. Done, guys? In all calculation of projectile motion, time is essential component. So one must learn how to find the time of flight. So once you are able to find the time of flight, you can do miracle. Siddhant, Harry, are you guys getting the time of flight?
So 2 minutes. Sir, is the time of flight u by g cot theta?
U by G cos theta. No,
Cot
I don't.
theta.
Cot theta. Probably no, that's not.
Sir, is it U by G sine theta?
I don't think so. Let me just see this. How much you are saying? Once again. Yeah, just
U
just
by
one.
G sine theta.
U by G sin theta. Earlier, what you said earlier?
No, sir, earlier I don't think so.
So what you can do is you can draw a line parallel to the plane here itself. Okay. And then draw a line perpendicular to this. Then this will make things easier for you. Okay. Just okay.
Sir, I got time of flight as U by G tan theta.
Then, yeah, maybe. So that should work. So if this is U, if this is U, actually, this is U. So this is theta given to us. Can you find this angle? This angle is how much? This is also theta, right? Can you see this is also theta?
Yes, sir.
Yes, sir.
And therefore this angle is also theta. So if this is u is horizontal, this is u cos theta. So if I make it better, because this is given as u, this will become u cos theta. But if you are hitting at right angle, you are hitting like this. So your velocity here is how much? In the same direction, it is 0, isn't it? Do you realize this? The
Yes.
velocity in the direction of plane is 0 eventually when you are hitting. If we call x dash, what is 0 here? Vx dash is 0, isn't it? So to get the time of flight, we can get this the answer directly. So we can write Vx dash equals to. Okay, now the question which is important is what is Vx dash? This is 0. What is Ux dash? U cos theta. What is Ax dash? We know this. Ax dash is how much? Come on, tell me.
Sir,
What is Ax
minus g
dash?
sin theta.
Very good. So that T turns out to be how much? U by G tan theta, which is correct answer. I think Harry has got this answer right. I think you
Sir,
also got the
earlier
same answer. No?
I said this u by g
yeah.
cot theta. I said.
Yeah, that's correct. Then why change? That was correct answer. Now, the question is still, we got the time of flight. What else we need to, get this into picture? Like we need to make this perpendicular. So the H must be involved. Okay. So what else you can do? You need one more relation. There are many ways. The easier one I can show you. If you draw perpendicular from here, in the same time, how much you have traveled horizontally? Ut, isn't it? Your actual velocity is horizontal, so you will travel how much? Ut horizontally in the same time? Yes or no?
Yes, sir.
And because I have thrown something horizontally, so it will fall down by what value in the same time? Gravity will pull you down by what value? Can you guess?
Half
How
G.
much gravity will pull you down? Displacement due to gravity is how much?
Half GT square.
So the remaining height will be how much? This will be how much?
H minus half gt square.
Very good. And now you're done. You know why? Because tan or theta in this triangle, you can name it, let's say O, A, B. So in triangle, there are many ways, but I'm taking the easiest route. So you can add tan theta equals to. So tan theta is H by UT minus GT by 2U. You can simply substitute the T value to rearrange and get the answer. So tan theta is H by UT. T is how much? So can you rearrange and solve for the T? Because this is easier, right? So tan theta plus cot theta by 2 is dH by U square cot theta, tan theta. Okay, anyway, multiply with. Can we write like this? Tell me. And if you multiply inside, what will happen? This is 1 plus cot square theta by 2. So u square is how much? So this is your answer. There are other ways of doing it also. You can solve for the displacement and you can also find the time of flight. The idea is the time of flight now we can determine in two ways, one using the displacement relation, another using the velocity relation. Because you can clearly see how much you have fallen in the widest direction. Can you realize this? You have gone down by h cos theta, isn't it? So in the y dash direction, you can see your displacement is how much? H cos theta. How many of you are able to see this?
Yes, sir.
Yes, sir.
Okay. So you all can see, right?
Yes, sir.
So you can also use that relation because you know the displacement, you can use the second canonical equation to relate those things. And because we can find the time in two possible ways. So our job is to substitute the time in one, the way you got in one, using the velocity relation into the displacement relation, and you can solve to get the speed. Okay. So you have to think that way. So there is one last question here. I'll give you directly from the book itself so that. So open the sheet. You have sheet, resonance sheet, I hope so. For the projectile motion, everyone.
Yes.
Open it. Okay. So the question which you solved is on the page number 17, question number 4. You can see that you have just solved. Can you see now?
So which question?
Page number 17. Go to page number 17. And you can see question number 4. This is what you solved, right?
Yes, sir.
Yeah.
Yes.
Now go above. Where is he? Oh, I think it's not here. Just if it is not here, then we have to go. Yeah, it's here. Then go to page number 13. Page number 13. Everyone there?
Yes, sir.
You can see comprehension 2.
Yes.
Solve it. To choose the proper coordinate system to make this easier. I think the two planes are mutually perpendicular, so it's always convenient to choose one as x dash, other as y dash. And resolve everything, and then hopefully we get all answers. So solve this question 4, 5, 6, 7. Done, guys? So do I need to solve now? Harry, Siddhant, tell me. Rugved.
So 1 second.
Sir, only one question is written.
Rugved, are you solving? Prasansha, are you solving this?
Yes, so last two questions remain.
Okay. Once you are done, just let me know. I'll start something new.
Done, sir.
Very good. All done? All four?
Yes, sir.
All right. So tell me, guys, if I need to explain.
Done, sir.
Very good. Rugved, how many you solved so far? So now we are going to start a new chapter. Okay.
So can you please explain the third and the fourth one?
Yeah. I need to explain all four. I think. Just, yeah. So we have two inclined planes at the right angle mutually perpendicular. So luckily this is 90 degree and we are throwing from height h, which is speed u, and it is also hitting at a right angle. This is given to you. Okay. This is speed. So can you find the time of flight? I think it's very easy to find the time of flight if you choose this as the x dash and y dash. Correct? So to find the time of flight from P to Q, how much you got to answer time of flight? I think many of you have solved, right? So you can add a Vx dash equals to 0, or you can make it the displacement relation also the way you want. So Vx dash is 0 means ux dash plus ax dash into t equals to 0. What is ux dash? What is ux dash? Am I audible? I
Yes.
think so. So what is ux dash? Tell me.
U
Ux dash is u itself, right? What is ax dash?
G cos
G cos
30 minus
minus g cos 30, or you can say minus g sin 60. Same thing. Either you say cos 30 or sin 60, it's the same thing, because there are many ways to express the answer. So this is called theta, this is 60 degree. This is 30. So what you're saying is correct. So g cos 30, which is same as g sin 60. So g cos 30. Okay. So into t equals to 0. So t becomes how much? U by g root 3 by 2. What is given u? I think u is given to you, right? 10 root 3. 10 root 3 by 2. So 2 second is the answer, right? So tell me how many of you got 2 seconds?
sir. I don't.
Yes, same.
Yes,
Same.
sir.
The speed with which the particle strikes the plane OB. So how to find V? I think that's also easy. No? How to find V? The third mathematical question will give you the answer directly. Because here we have to, V means what? V itself is Vy dash. So V square, what is Uy dash? 0. Correct? There's nothing there in the beginning. Plus 2. What is Ay dash? Tell me guys, what is Ay dash? Ay dash is how much? Minus G cos 60, or you can say whatever. Hello, hello, am I audible?
Yes, sir.
Yes, sir.
What is Y? Y is 0. What is Y not dash? So that you have to calculate from this triangle. This triangle you can see. H, this is sec. You can call this as something D. So D sine D sine 30 is H. So D becomes how much? 2H, right? And you're done. Ah, it's 2GH. So the answer is 2G itself, right? This is the answer. You can see the answer, right? So what is 2GH? 2GH. H is how much? Is it H given? No. H is not given.
No, sir, it's not.
Okay. Okay, the H is asking the question itself. Okay, fine. Just a minute. That's fine. So we got the formula for the V equals to under 2H. Let's see. So we need to find the V in other way, by knowing some other quantity. So because we know the time of flight, so we can write V equals to, that's easy. Vy dash equals to Uy dash plus Ay dash into T, that's it. So it's done, no? Because oh, this Vy now, we are writing Vy dash. So Vy dash is V. This is 0. What is Ay dash? Tell me, guys. What was Ay dash? Ay dash minus G sin 30, right?
Yes, sir.
Minus G by 2, and time we know now. This is 2. So V is minus 10 meter per second. That's simple. This is 10. So I hope you got the got this answer also, right? And now you can use the third equation to get H. So now you can substitute here, you will get the answer. 10 square equals to 2GH. So H is 5. Hmm? Correct? And the distance PQ, what is PQ? You can use the Pythagoras. So there are many ways you can solve. So you can find the coordinate. So you just need to find this also. This is D dash. Oh, whatever. So what is D dash here? The displacement along the X dash. So you can find that also. And once you find the D and D dash, you can use the Pythagoras. So the PQ will be how much? D square plus D dash square. It's easy. So can you solve now? The 6th and 7th part. 6th we did. 7th you should get the answer. Can you find D dash now? Tell me.
Yes, sir.
Go ahead and solve it.
So is it 20?
You can check the answer, it's given. If you go below, you can see the answer here, right? Rugved, Siddhant, tell me what is the answer?
Yes, sir. 20.
20. So I think that's correct answer. If everyone is getting the answer. Harry, you got the answer 20?
Yes, sir.
Very good. So now, since we have almost finished this chapter of projectile motion, tell me guys, what was your learning experience? What you learned, like the approach, the method, and how you are still going about the problems? Are you trying to mug up the formula, or the concept is good enough to arrive at the answer? Shared experience.
So one thing I learned is in every question, once you make the coordinate system and you find the components, it becomes very easy. So,
Correct. Very good. Anybody else who would like to share their experience? What was the learning from all this kinematics? Questions, tell me, what was your experience?
So same, the coordinate system, it becomes very easy after you get how to resolve.
Okay. So, any of you are feeling that, okay, formula is not required, the basic, the Cartesian system method is sufficient to get any answer? Okay. Now, one thing that I have realized, that is true for all of you, that apart from this method of doing through component, as you grow, as you grow as a student, as a learner, the vector will be more powerful tool, which will make you really powerful in terms of solving really fast question. So what I will urge is that every time if I have given some vector technique or method, try to accept it, try to also learn that way also. Apart from, see, because you have already mastered the component method, I can see that most of you are very much comfortable and you know how to proceed with component. So now, because you have learned one thing, which is the most important part of this chapter, now you can play with the other ideas, okay? And see that how effectively and how fast you can solve a numerical. So our journey from here onwards is all about, understanding the component. So if you're really good with, resolving something into component without any delay, as quick as possible, you will see that this ability will help you tremendously in every next chapter which we are going to learn. Okay. So that is going to be our future. We are going to resolve things quickly and then see the world of laws of motion, friction, and so on. Anybody else would like to share the experience? Maybe Rugved can share the experience.
There is no need to mug up formulas, all are basic kinematical derivation.
Yeah. So do you find any change in your approach since you started this chapter and now we are almost about to end this chapter? How much change you saw in yourself in terms of approaching the problem before and after?
Yes,
So
now
share the part that how you used to attempt earlier and what was your thinking that time, and now how you think of right now.
earlier it was just a formula and it was just given, but there was no derivation of it. Now we can derive it ourselves and do it.
Great. So anybody else who would like to share something about their learning experience in kinematics? Because this is the first milestone we have almost achieved in the world of physics. And it was indeed the difficult one. Let me tell you that as you proceed, further, there is a now things will be easier for some time. Again, it will become slightly more complex at the end of rotational dynamics. But before that, things are going to be easier and easier and easier. So the difficult part is gone. And if you have learned the right approach, then I am the winner actually. Okay, because my struggle will be less in the coming chapters. So still, I'm putting so many effort in kinematics because I really want all of you to be a person who can think from scratch and get the answer without trying to remember any single formula. And the reason is obvious because as we move forward, the content of this, the subject will explode exponentially, and then it is impossible to hold or keep the hold of the entire idea by simply knowing the formula. Okay. So whether any good student who is, qualifies the JEE, or whether if like teachers like us, the method of learning was same. Okay. So I want all of you to learn the method. I mean, not the formula. Formula is something which you can always derive because you cannot keep track of thousands of formula in the entire physics. And similarly, I want you to apply the same approach in maths and chemistry also, please. So I don't know what is happening there, but I'll still insist that all of you do try to maintain the same or try to develop the same approach in mathematics also, that if you don't know any formula, how you can derive from scratch. Okay. So if that approach will come to you, then you will find the entire preparation really fun. You will enjoy this preparation. Else the burden will always remain same. Okay. So now we can move to a really new concept, and that's called relative motion. In fact, every motion that we have so far talked about was a relative motion itself, but mostly the observer was at ground and looking at the situation. So you can say that the observation so far that we have, taken into consideration was uh, a ground frame observation. But it is not always necessary that the observer is always the ground frame. Let's say if you go with your friends for the skydiving, and then you see each other. Okay. Okay. So you all are falling down, but do you really see that you all are falling down? What you see? You see that you all are together. Okay. And then you see yourself downward, you can see, oh, yeah, I'm approaching towards Earth. Okay. Or if you're in a plane, then you see that the plane is not moving at all. Okay. So you try to look at the surrounding clouds, and then you realize that, oh, no, plane is moving. Okay. So if there is no cloud, we'll be able to see the motion the way we see at, at the ground actually here. So what really goes in our mind when it comes to motion? Can you tell me? So when you are driving your bicycle in the lane of your building, apartment, or side anywhere, even though you are riding at a speed of 10 km/h, it looks really fast. But a plane moving at 1000 km/h, and if you see the surrounding, do you really feel it moving that fast? 1000 km/h? Do you feel that 1000 km? Yes or no? So do you all realize that it's such a high speed 1000 km/h in which you are sitting the plane? They'll share your
No, sir.
experience.
No, sir.
Never. Okay. So what really matters? I mean, that's why we need to understand that how our brain perceives the motion is the change of surrounding. So imagine what happens to those, astronauts who go for the, interplanetary motion. So they are in the space ship and going far, far away. Do you really feel the motion? Because they are moving at a speed of 25,000 to 43 or 44,000 km/h. So they travel like roughly 50 km/h. In 2 hours, they will travel 1 lakh kilometer. So do they feel the motion? In the vast universe, you see mostly emptiness. And that is why, even though they are moving so fast, they don't feel anything. That's very interesting. So the whole idea of motion comes from the changing of surrounding. Okay, so the brain, the way our brain perceives the motion is the change of surrounding. Okay. So now if we talk about the event, okay, so there are some event which are very complex. If observed from the ground, let's say there is a caravan in which you all are dancing. Okay. And now if a person, let's say caravan is having the glass, boundary, okay, you can see through what is happening inside the caravan. And then there is an onlooker on the roadside. So there are lots of onlooker on the roadside. So if I try to observe the motion of any one person inside the caravan, it will be really complex because they're dancing also, they're moving also, isn't it? Because the bus is going, the caravan is going forward, you're dancing within that caravan. So how your motion will appear to the person on the ground? Isn't it really complex? Because you're turning, moving, and then moving forward as a whole. Okay. But for the person who is also inside the bus, the motion is relatively less complex. Okay. So the idea, the purpose of learning relative motion is to find a frame in which the motion appear less complex. So you may ask that, what is the benefit of finding that frame? Okay. So we talk about something called time. So time is invariant. Time is invariant in Newtonian world. Time is variant it is Einsteinian physics. What does it mean? Okay, so our syllabus is all about Newtonian physics, the physics as proposed by Newton and his contemporaries. So no matter which frame you choose to observe an event, listen very carefully, no matter which frame you choose to observe an event, the time taken will be same or different. Tell me, what your common experience says? So let's say if you slap someone, then everyone will see at the same time, or that event will appear at different time to different person. What will happen?
Same.
Same.
Now this view that an event happens at the same time, no matter who is observing it, no matter through which frame you observe, that called invariance. It means something which do not vary, we call invariant. And the beauty of the Newtonian physics is that time has been invariant. So no matter which frame you choose, the calculation of time will not change. And if that is the idea, why not choose the simplest frame? Why not choose a frame in which things are simple enough to, do the calculation with ease? So that was the motivation behind learning the relative motion, because time is invariant. Now, the same is not true in the world of Einstein physics. There is something called theory of relativity. And with the advent of theory of relativity, the time has become become variant, but that variation of time in terms of calculation never ever can affect our day-to-day life activities. So that is only true, or you can say meaningful, for the subatomic world, the world of electrons, protons, and subatomic particles. But the world in which we live, those variations are impossible to measure. Okay. So the reality is, yeah, the observation do not happen at the same time. And if you ask, sir, can you prove it? The answer is yes, I can prove it. So let's say this guy is watching and there is another guy who is also watching, and this is the event. Let's say there is an explosion of the bomb. Okay, there is some explosion. Okay. Now there is a third observer here also. So the event is observed through light. So light will travel up to you, then only you can see, isn't it? So how you see the event? How you see the event? Tell me, guys. Light. So we see because of light, isn't it? So until the light is not reaching your retina, can you see the event? Yes or no? The answer is no, you cannot see the event. And light will have some definite speed, some finite speed. In vacuum, it is roughly 3 into 10 power 8 meter per second. So the thing is, yeah, it's true that it will come to your eye in no time, but it is not coming at the same time for all, isn't it? And in fact, when you start moving, things will change even further. So if we take the motion of light into consideration as a mechanism of, the visualization, then time cannot be same for every observer looking at the same event, because light will take different time. Again, the difference of these measurements are negligible enough that our brain cannot perceive that the event is happening at different time. In the world of subatomic physics, subatomic world, these variations are fair enough, because the photon, which is called light, the photon is a very powerful for the electron. And when photon will hit the electron, in fact, electron will, kind of jump up. So they are so powerful for the subatomic world. And the observation can be very complex in the world of, you can say, subatomic world. Okay, so in the microscopic world, things are quite different than the macro world, and we live in the macro world, so we need not to worry about the same as of now. So whole idea is we are looking for, we are in the search of a frame which can make my calculation of time really simple. Okay, because time is invariant, and that is the philosophy of or the purpose of, or the benefit of learning relative motion. So motion, anyway, when we talk about motion, it is observer dependent event. Okay, so unless there's no one to say, you cannot explain the motion. So let's say if I put the blinds on your eye, and then if I take you to the outer space one fine day, and let's say there is no stars, no planet, there is no shiny object in the sky, you will have no clue what is happening where you are. And you have also no clue that whether the spaceship is moving really fast or it is at rest. You have no clue about it, because your brain cannot perceive anything. Okay. So the entire idea of motion will vanish for you. So you will be in a space that the motion becomes kind of, it will reduce to zero. I mean, you have no sense of motion. Okay. You will lose the entire sense of motion. So motion is always a relative event. So only a person who is observing some event, with respect to that guy, you can define the motion, because the motion means whether you are going away or coming closer to that observer, yes or no. Accordingly, we can define the motion. If your position from the given observer is not changing, we say there is no motion. So motion means the observer is seeing the change of position vector of that particle or not, will define the motion. Okay. So far we have been discussing the motion of individual particle in the ground frame without being mentioned explicitly. But now we are going to observe motion of one particle by another moving particle. Okay. So we are going to make the observation of two particles in which each particle can become observer, another becomes the event. Okay. So the one whom you choose as an observer will become the observer, and the remaining particle will become the event, which the observer will explain to you. Okay. So that is the whole idea of relative motion. It is relying on the fact that time is invariant, and therefore, since time is invariant in classical physics, therefore calculation of time from one frame to another frame remains unchanged. So we always search for a frame in which the observed phenomena appears in simplest form. So let me give you some simple real life examples just for you to realize. So imagine we have a wedge. Have you heard the name wedge? Like the famous potato wedges. So let's say we have a wedge, a triangular shape object. You can think as like this, something like this. So this we call wedge. Okay. And imagine that this wedge is moving. This wedge is not at rest, it is also moving. With some velocity. And there is a block which is sliding down the wedge, down the plane. Okay. So just to make it simple, I'll do like this. Okay. Let's say both are moving. So the block is also sliding. The wedge is also going right. Can you tell me how the block is moving? What is the direction of motion of block? So I'll draw 2, 3 arrows. You will tell me which direction is the direction of motion of block. Okay. So out of 1, 2, 3, 4, which are the possible direction of motion of block? If block and wedge both are moving, if the block is also sliding,
1.
so what is the direction of motion of block? 1, 2, 3, 4. Tell me.
So 1 or 2.
Sir, 2 or 3.
Excellent. Very good. It is 2 and 3. One cannot be the direction of motion, isn't it? Tell me why. When I'm not giving you any reference, it means I'm trying to observe from ground. So for the ground frame observer, is it possible for the block to move in the direction of 1? Tell me. Is it possible?
No, sir.
Because as you go down, the wedge will go forward. So can you continue moving in the one direction? No. The answer is the one cannot be the direction at all. That's impossible. What you need to realize, the block in the frame of wedge can move in the one direction, isn't it? If I ask you the next question that out of the 4 arrows, what will be the direction of motion of block with respect to wedge? So for this guy, let's say there's a guy sitting over here. For this guy, what is the motion that
One.
he will see? This guy will see the answer 1, isn't it? You know why? Because this guy is also moving with V. So the component which is common will never appear. Understood? So what will happen is now for this guy, for this observer, and there is one observer here. So for the ground frame observer, the motion is either 2 or 3. Well, but for this observer, the motion is 1. Now, every question of a relative motion you can break down into small information like this. Imagine this way. Imagine the block is not sliding. Imagine the block is not sliding. Tell me which of the following direction is the direction of motion of block? 1, 2, 3, 4. Tell me, if the block is not sliding, what will be its direction of motion?
4.
4.
It is going to be 4, yes or no?
Yes, sir.
Because only the wedge will, wedge will dictate the motion of the block because it is sticking to the wedge. So as the wedge will move, block will also move, yes or no? So in the absence of sliding, the block will follow path 4. The case 2. Imagine the wedge is at rest, only block is moving. Then which path? Imagine the wedge is at rest. Only block is sliding. Then which path will be the motion of the block? 1, 2, 3, 4.
1.
1. Very good. But now we have both events taking place simultaneously. So it means we have to talk about the resultant of 1 and 4. And the resultant of 1 and 4 will be anything between 1 and 4, yes or no? For any two vectors, the resultant will be what? For any two vectors, the resultant is going to be somewhere between the vectors. Tell me yes or no?
Yes.
Yes, sir.
And that is why when I asked you the first question that what will be the motion of the block in the ground frame, the answer was 2 and 3. So what 1 represents basically? Motion of block with respect to wedge. Can we say like this? Yes or no? Tell me.
Yes, sir.
Okay. And if the block is not sliding, if it is sticking to the wedge itself, then the path will be same as the wedge, which is 4. So now this is how we break down any event by asking that what if only this will happen? What if only this will happen? Because if you know what will happen as per one event, then you just need to superimpose the event and get the resultant effect. Okay. So that idea we'll also see. This is only for your visualization. Whenever you get stuck in a situation of a relative motion and you see that there are so many factors affecting the motion, take one factor at one time, ignore the other factor, and then at the end try to combine all the event and see what could be the possible way. So that is what you will learn eventually. But we'll start in a mathematical way about this chapter. So to begin with, now we have two particles which are performing motion in the ground frame. These two particles can be two cars, one car, truck, man, monkey, swimmer, boat, cruise, whatever, like anything in motion. So we also have the third person called the ground frame observer. So here the origin is representing what here? the origin, the XY coordinate system, which I have drawn here, what it is representing? This is representing ground frame observer. Okay. And this we call something like frame of reference, where you refer to. Like from which frame you refer to the event, we call frame of reference. What is frame of reference? What is the definition of frame of reference? So what is the definition of frame of reference? Tell me, guys. Anyone? Can you try defining the frame of reference? So there is a name to it. Any coordinate system, I'll tell you, a person can be called a policeman or an advocate or a, or you can say a doctor. So what you do is that to define the profession, we have some dress code, okay, in place. So it is easy to recognize a doctor by looking at the dress, okay, unless that guy is not an actor or actress. Similarly, for policemen, we have a different dress code which you see. And similarly, for other profession, we do have some dress code, except engineers don't have any dress code. Because that's not a profession, that's a way of life. Okay. So every profession will have some dress code, which is just to define. Similarly, every observer is a frame of reference. If you have a mathematical dress code, that's called a coordinate system, which could be Cartesian, polar, spherical, cylindrical, and there are roughly 300 to 400 coordinate system in the world of maths and physics. So what you know is just one or two. So you know the polar system, you know the Cartesian system. We do have the spherical coordinate system. We do have the cylindrical coordinate system. And the Cartesian is only up to the JEE level. So the moment you cross the JEE level, the moment you go for the masters or BSc, the coordinate system that we follow is more of less thoroughly the spherical and cylindrical coordinate system. If you go beyond that after masters, we go for the postdoc into the world of quantum relativity, then you will be brought about a new coordinate system, maybe the Hamiltonian generalized coordinate system, which is like much more advanced idea. And then beyond that, there are very specialized coordinate system for a suitable purpose of learning. So depending on what you're trying to learn, there is a suitable coordinate system which can make the writing, the literature much easier compared to what we know so far. So what you are seeing is a very narrow view of the world, that one coordinate system, you know, X, Y, and you may be feeling very happy about it, but there are many more coordinate systems, and these like dress code. Okay, so a dress code will give you certain power to perform certain action. So a Cartesian system will also give you some power to perform some mathematical action. That's, you can think that way. So what we say that any coordinate system attached to any observer is called frame of reference. Okay. Now the question is, do we need to have the frame of reference only something, a human being, something living, or it could be we can refer to anyone as the frame of reference? So the answer is we can refer to anyone as the frame of reference. So in fact, the ceiling of your room can be the frame of reference. The floor can be frame of reference. The moving plane can be frame of reference. it is like how you want to refer to the given observation. Okay. So because we are human being, we have such a powerful mind that we can also see the event through multiple frame being a single person. So I can also imagine that how things would have been if I would have been in that frame of reference. So that's like you refer to that frame in your brain, and then you try to explain to the world, see, if I would have been in this frame, the motion would have appeared to me this way. Okay. Although I am not there, but still the visualization, the thinking ability of human being is such that it is feasible for a human being to achieve such task of imagination. So a frame of reference is just an idea, that okay, how you want to refer to something. Okay, something means event. Event means some motion. Okay, so some action is happening, and you want to refer to that action by sitting in certain frame of reference, and then you give the mathematical details of the event, because without the, I mean, this address code, you don't have the power to perform the action. So without the coordinate system, we don't have the mathematical power to perform some mathematical action. So we need a coordinate system so that we can write something, we can express something, and that is what we do actually. Now, the relative motion at one time can be explained for one observer. Okay, so either I can explain your motion or you can explain my motion. Okay, because it could vary from person to person, so it is impossible that we can observe one motion with the help of two observers at the same time and giving you one answer. Every observer will give you a separate answer, so we can invoke or call only one observer at one time, and then we see the event. So we'll start with the two particle system. And the majority of questions that you will come across in JEE syllabus is only two particle motion or two particle system, in which you may choose one of them as the observer and other as the event. Okay. So now we start with two particle, but even to start with two particle, you need to have some reference to talk about them. So let's talk about them, the guy one, the person two, using a frame which I say ground frame or lab frame. So this is called either ground frame or lab frame. So most of the American textbook or their literature, they refer to lab frame. Most of Indian or British author, they use the word ground frame. This is just a convention. You can choose whatever you want to say. Now, this frame, we need to at least explain my first two particles. Let's call particle 1 and particle 2. And these are their position vector. So we can call R1 represents the location of the first person at any instant of time. It may not be always there. At some instant, when you click the photograph, you can see that they are at R1 and R2. So you may call this as initial position. You can say R01, R02, and so on. So as time will change, R1, R2 will keep on changing. And when I represent on a paper, then I represent for one particular instant. Okay. So now I am representing at one particular instant of time when this will happen. All right. So R1, R2 is representing the individual position vector with respect to another frame of reference, which as of now we are taking as lab frame or ground frame. Okay. I hope this is clear so far. Now, it is like a person at the origin. If you ask this guy, where is 1? So he will point the finger like this. And if you ask this guy, where is 2? He will point the finger like this. Okay. But now we would like to talk about something relative. Okay. So what will happen if I ask the guy 1, this guy, ask this guy, ask this person, where is 2? How he will point his finger? Tell me. If you ask the guy 1, where is 2? The finger he will point is like this. Yes or no? Tell me. So what this arrow represents, the last arrow which I have drawn. Let's draw with some other color. What is the physical significance of this arrow? Tell me.
Direction of 2 with respect to 1.
Very good. It is the position, not direction. It is the position of 2. This arrow is representing position vector direction. Yeah, of course, direction of position vector. Of which particle? 2 as per which person? 1, right?
1.
A slight reversal of direction will change the meaning totally. So what this arrow representing? So this arrow is representing position of 1 with respect to 2. So it means we have now 2 nomenclature, and this is also something very standard practice in physics, that if you want to denote the position vector of one particle with respect to another particle in which both are in motion, it is always good to use the double subscript notation. So we write here R, and this R is representing position vector of which particle? Tell me. This R is representing position vector of which particle? Can you tell me?
Position of 2 with respect to 1.
Very good. So this is position of 2. And whoever is referring to, we put after comma. So you are referring to 2, and the observer here is 1. If we do not mention the observer, it is by default ground. So when I write R1, basically it is R1 ground. So when I write R2, it is basically R2 ground. But it is like through convention, this is like understood. So we use single subscript notation if the observation is being made from the ground. Only if the observation is made from the other particle, we have to bring the double subscript notation. I hope this is clear to all of you. So do you realize the usage of single subscript notation and double subscript notation? Tell me, guys.
Yes, sir.
Yes, sir.
Similarly, if I write this arrow, I have to write this arrow as R. This arrow will be how much? R
1, 2.
1. See, the first alphabet is always the position vector. But if you bring something more, it will be the observer name. Okay. So R1 is the position vector, and then observer name is 2. So R21 is the position vector. I'm writing in short PV. Position vector of what? What this is representing? R21
Of 2 with
Position
respect
vector
to
of
1.
2 with respect.
of 2 with respect to observer name is 1. So similarly, R1, 2 will represent what?
Position vector of 1 with respect to 2.
Very good. So can we relate this relative position in terms of absolute position using triangle law? Yes or no? So how to express these two double subscript notation in terms of single subscript notation? What is R21 in terms of R1 and R2? So using triangle law, what you can write? So using triangle of vector addition, what you can write?
R1 plus R2, 1 is equal to R2.
Very good. R1 plus R2, 1 equals to R2. Now over the time, because we have become very lazy, as a generation, as a person. So in writing also, we have brought this laziness by omitting the comma. We just write R21. I hope you won't mind, because at the end, every engineer is lazy, but not the way you think, the way I think. So lazy means what? When I say lazy, it means a good engineer will not try to do something repetitive. So they design the entire software industry so that anything which is repetitive can be done by the computer itself. So when I say lazy, I mean that way. Okay. Something which is mundane job, a repetitive job, they don't want to do it again. So they are lazy to repeat the same thing. So they will try to develop some system in which those job can be done automatically. They will automate those meaningless job. Anyway, that's meaningless, lazy. So if R21 is R2 minus R1, it's very interesting to see that the order of the subscript is the order of difference also, right? R21 is 2 minus 1. So what do you think about R12? What do you expect?
R1 minus R2.
Correct? So the order of writing subscript and the difference is coming out to be same. So that is like a blessing. Now we need to get confused. So can I write R12 directly as 1 minus 2? Yes or no?
Yes.
Can we write? And once we have the relation of the position in the ground frame, so we can talk about the relative velocity. So this was the relative position. So what is the relative velocity? So relative velocity means at what rate the relative position is changing, isn't it? Are you getting the idea what I'm saying? Relative velocity means at what rate the relative position is changing. So what is V12? The meaning is what? Velocity of whom? What V12 will represent? Velocity of which particle?
One with respect to two.
1. So 1 is the event and observer here is
Two.
very good. So by definition, V12 we should write as d by dt of what? D by dt of
R12.
R12. Very good. And because R12 is R1 minus R2, so this will also become d by dt of R1 minus d by dt of R2. But the moment you come to the single subscript notation, what is the meaning of dr1 by dt? The actual velocity of the particle in the ground frame, yes or no? If you are differentiating the single subscript notation, you are referring to ground. True, guys? Tell me, yes or no?
Yes,
So
sir.
d by dt of R1 will represent what? The absolute velocity of the particle 1 in the ground frame. Can you call V1?
Yes, sir.
And d by dt of R2 will represent what? So what is V1, V2? Ground frame velocities of particle 1 and particle 2. Here, V1 and V2 it represents so here V1 and V2 represents ground frame velocity of velocities of So this is VU21. So what is it called relative acceleration? So what is a relative acceleration? So how at what rate the relative velocity is changing? The change of relative velocity with time is called relative acceleration. D by dt of what?
V12.
And therefore A12 becomes and how to write V12?
V1 minus V2.
Which means we can differentiate, we can get A1 minus A2. Yes or no?
Yes, sir.
Where A1, A2 represents the absolute acceleration of each particle in ground frame. Right, guys? Where A1 and A2 represents what? Represents acceleration of particles, particle 1 and 2. And there is no need to go beyond this. Up to acceleration, we end our kinematics, right? So we need to go the jerk, the other definition, pop, slice, whatever, slap, and whatever. So the whole idea is the motion of the relative world of motion. We are going to discuss two at a time. So we'll always discuss the motion of one particle with respect to another particle. So it is the one particle becomes the observer, other becomes the event, and we look for it and we try to report those answers to the someone else. So V12 means how one will report the velocity of two. And now let's try to understand organically, not by the formula itself. Organically, try to understand this. A very common example will let you understand this relative motion with very ease. Imagine a bus is moving, a car is moving, a bike is moving with velocity v, or let's call v1. Okay. And there is a guy who is sitting somewhere here. Okay. Now, if you think this is the one, this is two, and two is doing nothing in the ground frame, we all know two is doing nothing. But as I said, motion is frame dependent. It means motion is what the observer says to you, because what he sees or she sees the event. So what is the velocity of the person with respect to himself? If you start running, what will your velocity with respect to you? Tell me.
0.
0. Because can you go away from yourself?
No.
The answer is no. Now, see, there is a difference. We are talking about observation, not about your information or the knowledge which you have in your brain. You are supposed to report the observation, not your idea, not your knowledge. Okay. So sometimes what happens when I ask this question to a student, that there is a bus in which you and your friends are sitting together and the bus is in motion. So if you look at your friend is in motion or at rest?
Yes.
It is at rest, right? Now you know that you both are in motion, but if I ask you that your friend is at rest or motion, what you will say to me? You will say that your friend is at what? Rest or motion? Question is not clear to all of you, or is it clear? You and your friend is busing, are sitting in a bus, okay, and bus is in motion. Yes, I give you a call and ask you that what you see about your friend. Your friend is at rest or is in motion?
Rest.
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 Rest. Because You only, quote what you see, not what you know. Okay, so the seeing, the observation is what you see. You have to remove what you feel, because sometimes the feeling and the seeing, contradict each other. And that's why it's become difficult to solve numericals, because we start applying our emotions and we fail to become the observer. Okay, so now you all have to become observer, not the emotional person. Okay, because you have to answer as per the requirement of physics, not as per what you feel from within. Okay, so let's say there are two person who jumps off a helicopter. Maybe this is the Mission Impossible N number, and the Tom Cruise is jumping off the airplane, which is very typical of Tom Cruise. So now tell me, if he is jumping along with some of his friend, and if I ask Tom Cruise about his friend, that is your friend falling downward, what he will say?
No.
Very good. So if you or your friend all jump together, then a person on the ground will say that you both are in acceleration, you both are accelerating downward. Yes or no? So two person is jumping off the plane, ignore the air resistance. They are falling under gravity, and there's a person on the ground. If you ask the person on the ground that both are moving down with some acceleration, the answer will be yes or no.
Yes.
But if I ask you about your friend, then will you say your friend is accepting downward, or will you say that your friend is at rest? What will you say?
At rest.
At rest. Very. It means we are only supposed to quote what we see, not what we feel or what we know. This demarcation, this distinction is very, very important to be, born in the mind while solving numerical. That you're not supposed to apply the emotion. Think about realistically as much as possible and try to see. So now look at this question, this example. If I ask one, what is the velocity of two? What he will say?
Minus V.
Minus v naught.
Yes, sir.
So he will say that it is having velocity v naught in the opposite direction, isn't it? Now this is what is being said by this. This is the velocity of two with respect to one, and in vector form it is minus v naught, correct? So even though two is having nothing, but for this observer, two is having at least this much. Are you getting a point? What is happening?
Yes.
Two is having nothing, but for this guy, one, for the guy one, the two is having minus v naught, which is exactly opposite of what one is having in the ground frame. Okay. So in the old Hindi movies, there is a dialogue when you go and touch the feet of some elder, they will tell you, "Meri umar tumhe lag jaye." Have you heard this phrase somewhere? "Meri umar tumhe lag jaye." No. No. Now this guy who is the observer, the moment you become observer, will you see anything about yourself? If you become the observer, and if I ask you, what is your position with respect to yourself, what will you say? How far are you from yourself? The answer is 0. If I ask you, what is your velocity with respect to yourself, what is the answer?
0.
0. What is your acceleration with respect to yourself? The answer is
0.
the moment you become observer, you become some sort of saint. And saint will be, releasing all the worldly pleasures. It means you're free from all the action. You are the one who is going to observe others' action. And to make you free, because you are free, so whatever you have in terms of velocity, acceleration, or position, that will be assigned to other guy, but with a change. And what is the change? In the assigning process, it will be always opposite. Understood? So one had a velocity v naught, but the moment one becomes observer, it will give its velocity to everybody else in the world, but in opposite direction. Understood? So imagine this way. Let's say we have many particles. V1, V2, V3. Okay. Let's say these are three fighter plane flying by three pilots. And suddenly, let's say you are in the sky on a mission, you are flying a Rafale now. The 2 becomes the observer. 2 is the leader. Let's say 2 is the observer. So what 2 will see about 1 and 3? If 2 is my observer, the day you decide to be observer, you have nothing. Then this becomes a rest. And everything that you have, you will give it to. What will do? You will give it to others. But in opposite direction. And what other is having already, that is always there. So जो तेरा है वो तेरा है, जो मेरा है वो भी तेरा है. So what you have is yours only. But what I had now will be yours in the opposite direction. That is the whole idea of relative motion. So now what is the velocity of 1 with respect to 2? You can say either V2 minus V1 backward or V1 minus V2 forward. Yes or no?
Yes, sir.
If I ask what is the velocity of 3 with respect to 2, what you will say?
V3 minus V2 forward.
Or
V2 minus V3 backward.
correct. How many of you are able to realize this?
Yes, sir.
Everyone? So imagine, let's do some practice first before we actually solve numerical, which we will do probably in the next class. Today we'll try to just understand the basic. So let's say there are 2 guys. So one is moving this way and other is going this way. Imagine these are mutually perpendicular. Draw the vector diagram for V21 and V12. So draw the arrows and join the arrow tail to tail to draw this vector diagram. So how the V21 will look like? So V21, velocity of 2 with respect to 1. Now who is the observer here?
1.
1.
So 1 will give its own value to the other and 2 will continue with its own value, isn't it? So how the vector diagram will be? Isn't it like this and like this? I'm writing this as a value and with arrow. Correct?
Yes, sir.
Can we say this is V21 vector representation? See, what you have is yours only. Because the day I choose to become the observer, I'll give all of my velocity to others in the opposite direction. That's the definition. V21 is V2 minus V1. So I'll tell you like what is the vector meaning of V2 as well. It means V2 plus of minus V1, which is the resultant of 2 and opposite of V1. That is the meaning of V21. What is V21 once again? It is the resultant of second vector and inverse of, or you can say reverse of first vector. Isn't it? So what is V12, guys? V1 minus V2. This means V1 and minus of V2. If you go and watch my vector lecture, you can see all this meaning, right? I have discussed in detail. So how the V12 will look like, guys? The vector diagram will be. So do not alter the V1 the way it is. Keep it as such. And 2 will add in which direction? Left to right, up, down, where?
Left.
It means your actual motion as seen by the first observer. This is V12. So you will be moving in which direction? In this direction. Something like this. This is V12 direction. And here, so it will appear to me that you are going this way. Is this clear?
Yes.
While solving kinematics, if we come across a relative motion of two moving objects, and if we know that they start with same initial velocity, so anything which is same will never appear in a relative, isn't it? So let's say if you have 20 rupees, I have 10 rupees. How much richer you are? Only 10, right? If you have 120 rupees, I have 100 rupees. So relatively, you are having more money than me. By what value? Am I audible, guys?
Yes, sir.
So if you have 120 rupees and I have 100 rupees, then how much extra you have?
20 rupees.
But if you have, let's say 220 and I have 200, then how much extra you have?
20.
So when you do the relative calculation, what doesn't matter is this common term, isn't it? Which means 200 and 220. What is common to both of us? 200. And similarly, 120 and 100, what is common to both of us? 100. And if you have 20, I have nothing, then what is common to us? The nothing part. The idea is, if two particles having something similar, in the relative, that will vanish. Because if something is similar, the relative, it will not exist, because the difference will become 0, isn't it? And that is why if both particles are moving with the same velocity in the same direction, so what is V12 here? Velocity of one with respect to two. So one will have its own value, V, and two will give you V like this. What is the answer? Tell me. Hello, hello, hello. Am I audible?
Yes, sir.
So if two particles are having same velocity in the same, of course, direction, the relative will be how much?
0.
0. It means both will see each other at rest only, na? Isn't it?
Yes, sir.
But if I am moving towards right and you are moving towards left, what is the relative velocity of 1, 2, or 2, 1?
2B.
So numerically, it is either plus 2b or minus 2b, right? Depending on how we choose the direction. So the modulus will be always 2b. Am I right? So if two objects are moving in the opposite direction, the relative becomes double. Yes or no?
Yes, sir.
And that is why when you travel in a train, and if a train is going this way on the other track and you're moving in this way on the other track, then they cross each other very fast, isn't it? Because the relative velocity will add up. So what is the relative velocity? How much is that?
V1 plus V2.
It is the sum of it. Am I right? And that's why they cross each other very fast. Quickly, because the relative is more. But if they travel in the same direction, then have you seen they cross each other in less time, more time, because the relative is what?
Their velocities are separate.
Yeah. So let's say we have, you can say two coaches, railway coaches, let's say of length L1 and length L2. And if I have given the velocity as this as V1, this as V2, how much time it will take to cross each other completely? So to cross each other, completely, you can choose one of them as observer, right? Tell me which one you want to choose observer.
L2.
L2. So L2 will have nothing now. L2 is at rest. So let's say you're saying that, okay, I'm going to choose L2 as observer. So to cross this observer, how much L1 has to travel now?
L1 plus L2.
So do you guys realize this part, that this you have to travel L1 plus L2? And with what speed you are traveling as per the observer?
V1 plus V2.
So time taken to cross will be how much? Total displacement upon total speed, the relative speed, yes or no? So you will cross each other in this much time. Okay.
So L1 only travels distance L2, right? How is it L1 plus L2?
How to cross? So let's say if I travel, as you're saying, only L2, I'm here. Am I crossing now? So to cross, I have to travel further this much. Now it is crossing, no? Yes or no?
Yes, sir.
How much you traveled?
L1 plus L2.
It's like your rear part and the front part should match. Then only we cross, no? Cross means what? This point should be here. Yes or no?
Yes.
So how far is these 2 points? You can see clearly it's L1 plus L2. Yes or no? Correct? And so if I ask you this question, so we have two coaches, L1 and L2. I'll call this as L2, this as L1. And both are moving in the same direction, but with a different velocity. In fact, the rear is moving faster than the front. So eventually two will chase the one, right? So when this will cross this point? So time to cross will be? Tell me, guys.
L1 plus L2 by V2 minus V1.
L1 plus L2 by V2 minus V1. How many of you realize this? Everyone?
Yes, sir.
Anyone finding this difficult, please raise your hand. You all are okay with this question? Tell me, guys, yes or no?
Yes, sir.
Okay, so this is something very simple, like you can just play with the vector diagram and you can solve most of the question. So we'll write the kinematical equation for constant relative acceleration. Imagine if your acceleration is constant, my acceleration is constant. So relative is going to be constant only, yes or no? Tell me. If two particles are having constant acceleration in the ground frame, Can we say their relative acceleration will also be constant? Yes or no? Can we say?
Yes, sir.
So we can use the kinematical equation. In a relative form. So kinematical equation in relative form. So how we write? Just it's very simple. First of all, you need to write in vector form. First of all, so you cannot write v equals to u plus at. You have to write v vector, u vector, a vector into t. Simple, fair enough. And then just use the subscript. Now you have two choices. Either you can start with 1, 2 or with 2, 1. The simple rule is if you start with 1, 2, continue everywhere. While solving, you can expand. And you can clearly understand that if I switch the order, the overall equation remains unchanged, right? Do you realize this? It really doesn't matter whether I write 1, 2 or 2, 1. Okay. Is this okay? Yes or no? Tell me, guys.
Yes, sir.
Yes, sir.
Now, again, there are two questions. This could be a one-dimensional relative motion, or this could be two-dimensional. If it is two-dimensional, then put I, J, K and write components. If it is one dimension, just take a right as positive, left as negative, and again put with sign, proper sign. You won't face any difficulty of solving. So imagine you want to write the second canonical equation. Just okay, let's write the second canonical equation. What is the second equation? A is equals to ut plus half t square, but because we have to write in vector form, how we write? R minus R naught, it is final position minus initial position equals to ut plus half a t square. Now to convert this into a relative form, you can add 1, 2, 1, 2, 1, 2, 1. That's it. And if you want to expand further, while solving, you can expand, but writing here is not required. So write the difference of final position, the difference of initial position, the difference of initial velocity, the difference of initial acceleration. And you can clearly see that the moment you make a initial value similar for both, let's say if the two particles are having similar acceleration, what will happen? So that's a very famous question. If A1 equals to A2 in direction and magnitude both, then 2 implies tell me what will happen. The equation becomes so from a quadratic relation, now we have reduced to the linear relation. Okay. And that is the beauty. The position will follow the a linear relationship with time, which means with same acceleration, the path of one particle as observed by other particle cannot be parabolic. What will be the path of one particle with respect to other particle having same
Straight line.
acceleration? It is always a straight line. It means when you are free falling, and if all the particles are having same acceleration, then the acceleration term will go away. It is for none actually, because all are having same acceleration. So relatively they have no acceleration, and therefore the path of any particle as seen by the other will be perfectly straight line. Understood? Are you getting this idea what I'm saying?
Yes.
So this is a special case. This implies something very interesting, and that is if A relative is 0, then path of and the reason is fair enough. Let's say if I throw something with velocity v1, if I throw something with velocity v2, in time t, you will travel how much? v1t. If you remember from the projectile motion, how much you will travel? v1t. And this will travel. And gravity will bring you down by half gt square and half gt square for both. So none of them will feel that they have gone down, isn't it? So the the fall will never appear to each other, because this entire line as a whole has come here. You can think this way. So they will never see the motion to be parabolic. What you will see is the straight line motion. Mathematically, you can also verify, but logically, you can think that okay, both events are happening in the same way. And this idea I have been using even in projectile motion. So to say that here in fact, so if there is, let's say if the moment you throw this particle, I also jump from the sky and I become the observer. Okay. So now observer is also free falling. There's some very passionate observer about physics. He jumps from the space just to make this observation. This guy will never see gravity. So this guy will see that this particle is going to like this. Understood? So for this observer, you don't have any acceleration. So you will go like this only, isn't it? Do you realize this?
Yes.
But in reality, this line will not be here. This line will be now here because in the same time, the line will fall by half VT square. So this observer will fall with half VT square, and so you will also fall by the same value. Therefore, this motion is not visible to this guy. So he will see that you are going this way. So that is why when we solve question like this, I said, okay, you can think this is going this way and then falling this way. There are many ways of solving questions. Okay. Anyway, we'll come to this also. So in every canonical question, just put the words REL called relative and you are done with it. So you can write a V relative equals to U relative. And in your mind, just write like this into T. And then you can say delta R relative is a U relative into T plus half A relative into T square. And the third equation we can also write for one dimension, but for one dimension. Because third is not a vector equation. So third cannot be written for 2 dimension because it's a square term and vector cannot be squared. And it will also remain vector. So once you square a vector, it is no longer vector, it's a magnitude. So therefore, the third equation is we cannot write in vector form. The way we can write is like this. Yeah. We can let's write for the X or any for one dimension. So you can write like this for one dimension, but we don't have the vector relation for 2 dimension. Okay, I hope this is clear. So we'll see some of the application, not some, a large number of application of this idea. Just before I wrap up, let me show you just one last question, but I think you have some other lecture, right? Siddhant, you
Yes,
have
sir.
lecture? Yeah. All right, so we'll continue the same thing in the next lecture. The next lecture is going to be completely relative motion. And we'll see there are 3-4 varieties of question that we have to study. The rainman problem, the riverboat problem. We have the projectile motion, the JEE kind of problem. And then we have the velocity of approach. So that will take at least 2 to 3 lectures to finish the entire relative motion. So I'm going to share the PDF of relative motion. Even though you don't know relative, you can solve by the common sense, by the same canonical equation. Relative motion is just one strategy to make it easier. That's it. Bye guys, take care. See you in the next lecture.
Bye, sir. Thank you, sir.
And finish
Bye,
your
Siddhant, sir.
finish your projectile motion completely. Okay. Also the ALP problem.